In search of soil.
So today I'm here with Troy from Living Roots Compost Tea in Tennessee. And Troy, one of the things I wanted to start out with is this topic that keeps coming up over and over in a lot of the interviews and people I talk to is around compost, and it involves the quality of compost. How can somebody who makes their own compost, purchases in their own compost, evaluate the quality of that when they want to use it either as compost or in a tea, which we'll eventually get to in this interview?
Right. I mean, the best way is going to be with a microscope. I understand that most people are not going to have a microscope, but I focused I focus strictly on the biology in compost and compost tea soils. So um, any compost that I'm looking at, I'm trying to see, has it got good bacteria, good fungi, nematodes, protozoa, and wanting to see quality wise, just strictly on the biology. So to me, a good compost is going to have all characters of the soil food web. Um, I mean, just kind of using your naked eye when you're looking at a compost from a compost facility, I would say just in general, most large scale compost facilities are not necessarily going to be making that great of compost because they're focusing on waste reduction more than a quality compost. They're trying to focus on taking a waste product and breaking it down for someone on a super large scale. And when you're on that large of a scale, it's kind of hard to focus on quality. I'm not saying that everyone doesn't focus on quality. I just haven't come across many companies that are very large that, make great compost biologically speaking. But if you get a compost, you want to be looking for various degrees of decomposition in the material. So, there may be some wood chips, but you kind of have to think of those wood chips. If you've got good biology there, they're going to be like a slow release fertilizer because they're going to be broken down over time, and bacteria and fungi are going to eat away at it. They're going to hold those microorganisms, hold the nutrients inside themselves until a predator comes along and eats them, or they die and are then made available. The nutrients inside of them are then made available to plants to take up the nutrients. So if you notice you've got a compost with a lot of chunks in it, then it either hasn't fully gone through the composting process, or there may not be a lot of good biology there to be breaking it down. It's really hard to tell with the naked eye, but I usually look for signs in my own piles of are things turning into humus more quickly? Have I got mycelium like from saprophytic fungi on different pieces of wood chunks that are in there? So for people who aren't familiar with what mycelium looks like, if you ever go for a hike in the forest and you lift up some of the leaf litter or some sticks or something like that, and you see white strands on the bottom of a stick or leaves, that's mycelium, and it's from saprophytic fungi, which is fungi that breaks down dead or decaying matter. And then, so in your compost pile, if you notice these mycelium, you know that you've got good fungi going in there, and you should have some good bacteria going in there. It's a matter of having, all the characters though, because if we do have just bacteria and fungi in a soil or in compost, without getting into a lengthy explanation, they are the first decomposers. So on mainly green, easy to consume tissues, bacteria are going to consume those. And then more brown, woody tissue, fungi is going to feed on those. If you've got bacteria and fungi, you've got those things broken down, but all those nutrients from that organic matter are then held in the bacteria and fungi. But in order to get those nutrients and minerals to plants and into soils, we need their predators to come along and be able to eat them and release those nutrients in a plant available form. So that's the reason we need all the characters, not just bacteria and fungi. So we need to focus on building up all characters of the food web.
I think one misconception around compost or really any amendments is the plant is going in and mining nutrients out of those amendments. Like the root is tapping into that compost and absorbing some. And I think there probably is some liquid transfer there. If water goes down and leaches through, it's going to absorb that into the root. But really, the function of this compost, these amendments, are you are feeding the organisms. The organisms are consuming that compost. They're then consuming each other, and that poop, the excrement, and the dead bodies is what the plant can access?
Correct. Yeah. So for billions of years before humans were around on planet Earth, plants and microorganisms have had symbiotic relationships where plants, through photosynthesis, they create lots of energy and then they release carbohydrates, sugars, proteins into the soil that are foods. They're exudates that they're shedding off through their roots as they grow into the soil, like you were talking about. And they're feeding the microorganisms in the soil to bring those populations in. So, if you, as humans, if we want to make friends, what's one of the ways that we make friends? We invite people over for food. Or go out to eat with someone. So plants put out food to bring in microorganisms, and then it's a matter of that symbiotic relationship of the microorganisms being present in the rhizosphere then. So then when they are consumed, the plant is able to take up those nutrients. And the chemistry behind the plant taking up the nutrients is a bit beyond my knowledge. I don't have a chemistry background, so I'm not able to explain that, is what I'm trying to say.
One thing you mentioned is a lot of times in municipalities, the goal is reduction of size and quickly. They're moving through a lot of volume, and maybe that's sacrificing on quality. Somebody could also do that on a home scale. They might just be doing a composting method that's moving things along too fast and not allowing the diversity of organisms and the population of that diversity to really proliferate. Where's a mistake of large scale composting that we want to make sure we avoid on the small scale to end up with a quality product?
Well, usually with a large scale compost facility, they've got so much real estate that they can use that they're trying to make compost on, and they're trying to make compost and get it out the door to make money. So they need that land to be able to make more compost. So normally, in my experience from like things I've seen, experience with people like getting compost deliveries and stuff like that, you can see on Instagram, somebody gets a large delivery of compost and they're super excited, but you see it steaming. Well, if the compost is steaming, it's obviously hotter than the air temperature, and compost is finished when it's at ambient temperature. So whatever the temperature is outside, it should be close to that, within like 20 degrees or so. But the issue is that larger facilities it's not that they're getting it to break down too fast. It's that they're composting it, but then getting out the door before it's actually aged and matured. So you've still got hot compost that's breaking down, and it has the potential to harm plants if you were to not dilute it down into a potting soil or something like that. And it still could cause issues then, possibly. But yeah, the main issue with large scale facilities is that, and then, whatever starting materials that they're using may have some detrimental effects, because they might just kind of be throwing anything in there. On a home scale, so to kind of compare that to a home scale, it's really a matter of getting a good mixture of feedstock. So whatever you're putting into your compost pile, you want to have a good diversity of that. So you're getting a good diversity of microorganisms. You're going to have certain microorganisms on a banana peel, certain microorganisms on a piece of lettuce, other types of microorganisms and species on a stick and a leaf. So it's a matter of getting a diversity of that in your compost pile at home. And then focusing on the management. So like when I was working at Rodale with Elaine, we were trying to, so the organic regulations, to meet organic regulations for compost, you have to turn 5 times within 15 days and maintain a temperature over 131 degrees Fahrenheit. Well, with that with that management practice, you could have someone who goes out and is checking their temperatures every day, but they might be lazy or they might be too busy to turn a pile, or it might have rained and they can't get out into a muddy area where they're able to turn their compost. And then they're turning 5 times, the last 5 days of the 15 days that they're maintaining those high temps, they're turning once every day. So we were focusing on, at Aerated, we were working on trying a turning according to temperature, where your management practices are focused on the biology rather than just meeting regulations. Like turning according to temperature, you don't want to get above 161 degrees, because at 160 degrees, I don't know why I said 160 degrees or 165 and higher, the heat is coming from microorganisms that are reproducing and eating. So just like when we eat and reproduce, we create heat. That's where the heat in the pile comes from. So when you're at 160 degrees, you've got a lot going on, biology-wise, in that pile. And at that point, the oxygen is being used up at such a rapid rate that the pile is going to most likely go anaerobic on the inside. And once you go anaerobic, you get anaerobic microorganisms, which could start creating phenols and alcohols and things that are going to be detrimental to plants. So when we're turning according to temperature, we want to get up above 131 degrees, and then turn if you were to hit 160, 165 degrees to get air back into that material. Or if you notice a drop in temperature, if you were maintaining 145 degrees for like 3 days or so, that's just an example. Sudden the next day you come out and shit and you're at 135 or 130 degrees, something's going on inside that pile where anaerobic microorganisms have most likely started to take over, and you really need to get air in there. So when we're focusing on the biology, we're really looking at temperatures and moisture levels too. So making sure that a pile isn't getting too wet and maintaining 50% moisture. I like to compare composting to food preservation. So as humans, we use salts, dehydration, and airtight containers to basically keep microorganisms at bay. So if you've got food, the first things that come in and eat it are bacteria and mold, which is a type of fungi. And as humans, we're trying to preserve that food. So we dehydrate things. We take all the moisture out of there so that the microorganisms aren't able to break it down, or we keep it in airtight containers away from where oxygen's going to get to it and help those microorganisms to break it down. So in the opposite sense, when we want to enhance microbial populations, we need to really be focusing on moisture. So these microorganisms that I'm talking about live in little microfilms on the surfaces of organic matter. So that's why people talk about keeping a compost pile at 50% moisture, or the consistency of a wrung out sponge, so that we're able to provide a beneficial habitat for microorganisms that are going to thrive and succeed in breaking down these microorganisms. And that also involves, they need oxygen and moisture. So that's why it's important to incorporate both of those.
Lately, I've been doing a lot of reading and kind of fallen into this school of cold composting, where you are trying to employ the biological activity of fungi over bacteria, so that you leave the pile more passive. You're not turning as much. You're not concerned with temperature. And if we remove the regulatory aspect out of it, like for some people that doesn't matter on a garden scale.
Right.
Is there some validity to that if I maintain a pile with less turning, I'm enacting fungi more in the decomposition process and potentially preserving more carbon in the soil because there's less aerobic activity, which would then send carbon up into the atmosphere as a byproduct of that aerobic activity?
You are correct in that. It's not just cold composting, though. I it's been a while. I need to get it going again, but I ran an experiment on aerated static piles. Are you familiar with that? ASP? Right, forced air system. So you've got pipes laid on the ground that you, I don't know if you can see my fingers, but you would put material on the pipes like this and stack it up, and then you're forcing air up through that. And through my experiment with that, I had great results getting fungi going in the pile because I'm not turning it. So yes, the whole deal with fungi and my whole mission since I started making compost and doing what I'm doing is to get more fungal compost and get more fungi into the soil through our conventional agriculture practices, like using a tractor or having heavy machinery on the soil. It causes compaction, or especially tillage. A lot of people think that every spring they need to go out and take their tiller out and rip up the soil. So when I was talking before about that saprophytic fungi and seeing saprophytic fungi in the forest, when you notice that, it looks like strings on a stick or on leaves. And that's what's visible to our naked eye. But most of these things that I'm talking about aren't visible to our naked eye. So there's lots of things in the soil that we're not seeing. And there's tons of thread, just miles normally in a healthy, especially in a forest system, in a healthy soil. There's miles of fungi underfoot that if you were to come through, with a tiller, or in this, you're talking about compost, if we're getting this saprophytic fungi and these mycelium going throughout the pile, if you come through and turn that, you're ripping up all those threads and setting the stage back a lot earlier to, where there's more bacteria that are going to thrive, and that fungi needs more time to get going again.
So it's provide the oxygen, but don't break up that network.
Exactly. Yeah. Yep. And with cold composting, most people in their backyard are going to throw, they mow their lawn and maybe they collect some of the grass clippings. They're going to throw those in a pile. And then in the fall or in the end of summer, they might have a garden and they're throwing some of those scraps on there. And then the fall, they're throwing leaves in there and sticks and things like that. And if you're not turning that, it's most likely going to go through an anaerobic process because it doesn't have air in there. But if you leave it long enough, aerobic microorganisms are going to take over, and you will have good compost in the end, and hopefully have good fungi in there too because you haven't turned it. But it's a matter of letting it age and mature, like a year or a year and a half. And most people are wanting compost a lot quicker than that and not wanting to have to wait around.
Yeah, I mean, the more I read on this, I think that's the trade-off. People are rushing it, and I think they're giving up a lot of the value in that compost. Like, it's as though we say, well, it's better to have it on the soil now at a 5 than it is to wait for it for another 12 months and put it on the soil where maybe the effect on the soil is, I'm making this up, a 50 versus a 5, because those organisms have diversified, they've matured, there's more of them. You're just adding better quality, more concentrated stuff to the soil versus adding something that's good, but it's just quick.
Right. Yes, I totally agree. And in that sense, to me, if someone were to know to look at the biology of a compost and, like maybe got a sample, like they have a local municipal compost and they got a little sample and were able to look at it with a microscope and say it was a 5, like you talked about, well, they're going to have to spend more to pay for twice as much compost or whatever to get it down to get the same effects as if you were to let a compost age a little bit longer and then use less and have better biology on your soil. I noticed on your Instagram page that you had started a Johnson-Su reactor. So David Johnson had found out through his research that 1 ton of compost applied on an acre of land will get results. He's got fungal dominant compost. He's applying that at 1 ton per acre, which it's really hard to fathom 1 ton per acre. I mean, that's like probably 2 to 3 cubic yards of compost. So that's, I mean, you're probably not even going to be able to see that as you apply that down at that rate. But he got effects. He through his research, according to his research, he got effects where he had an effect on the biology in the soil then, and was able to get more fungi going in the soil with just 1 ton of compost. Whereas most people are putting down 10 tons of compost, at least, I would think, which is still, pretty minimal.
Isn't it all going to this fungally dominated compost anyway? So if we take that fungally dominated cold compost pile and it takes 18 months and we just let it sit there, and then we apply that, it's kind of as broken down as it's going to get. It's at its base nutrients at that point. Where if we take more raw compost after, let's say, 45 days of turning, we add that to the soil. It's going in as compost, but it's still going in the soil now, going to evolve and break down more by fungally dominated organisms into those base nutrients. So at the end of the day, after 18 months, you're kind of still getting the same thing, but one happened in the soil, one happened in the pile.
So if it's someone who's been not even necessarily cultivating by conventional means, but someone who's still been tilling and are organic, they may have been suppressing that fungi for so long or breaking it up that they don't really have much fungi in the soil. And if you take a compost that's half aged or whatever, you're most likely not going to have that same amount of fungi. The fungi hasn't been able to grow onto the surfaces more to take over to have that same amount of fungi. I'm trying to think of an analogy to this, but I can't think of one.
Well, it makes sense. You're better culturing it all out in one place where it's hyper concentrated in the perfect environment, building up the soil population by introducing that, than assuming that there's enough biology in the soil that can take care of the more raw ingredients you're putting into it.
Right. Yeah. So if you already have decent biology in the soil, it wouldn't be as big of a deal, because we really need to be feeding the soil. That's the whole kind of what we were getting at in the beginning of our conversation, is that it's not about feeding the plant. It's about feeding the soil, giving the soil what it needs. And then the soil is going to have interactions with the plant for the plant to manage its own nutrient needs and feed itself. So yeah, with that, putting compost down on something that already has good biology in the soil is just helping to add more organic matter to it. That's going to be foods for microorganisms that will help to give nutrients to the plant. So yeah, if you do have good biology in the soil, it wouldn't be as big of a deal to use more of a mulch compost that doesn't have as great of microbial populations in there.
For somebody at home that wants to evaluate their compost for fungal versus bacterial, how hard is it to do with a microscope, and what's involved? Like, what's the cost of a basic microscope to do that? I know there's classes online at places like Soil Food Web where you can learn to do it. I don't think we can't go into all the details because it's a very visual thing of what it takes, but how easy and costly is that to do?
You can get a microscope for, it's gone up a little bit. It's $315 or $320. Microscopenet.com has the brand that they normally have is a Omax microscope. To get specifically, if you want to look it up, it's the model M8311, I believe. I've had to look it up a lot of times. But yeah, that's $315 to be able to assess your own soils. Now, to be able to get the biomass of the fungi or bacteria in the soil or any other microorganisms, you'd have to set up a spreadsheet. So like I've got a spreadsheet that Elaine's continually updated, a spreadsheet that she has, and I've got one of the ones that she's put out in the past. It has functions in each cell that, take into consideration the number of views per cover slip and things like that, to be able to do the algebra and everything that you need to figure out what your biomass is going to be in, and from looking at one drop of compost or soil or whatever. So then, it's a matter of being able to identify the microorganisms that you're looking at, which really most people are asking me about that. And from my own experience, it's a matter of knowing what not to look at. So when I'm looking through a sample, first I scan for nematodes. So I'm mainly looking for movement I'm looking for like a snake or worm-like shape that's really moving or maybe staying still. And then as I'm focusing in more, I'm looking for fungi and protozoa, which is going to be like testate amoeba, flagellates. And it's a matter of knowing what their movements are and shapes and kind of sizes to know what you're looking at, and everything else. You don't want to necessarily ignore it, but there's a lot of things that you can ignore where most beginners who are using a microscope, they see all these shapes and they're like, ooh, that's so cool. And it's like, yeah, that's a piece of mineral. Like it's good that it's there, but we don't really need to focus on it. So it's really a matter of like knowing how to identify things, what you're looking at, and just spending a lot of time at the microscope to be able to do that. So you would have to most likely take at least one class to, get to learn how to identify microorganisms. And then also, like I said, you'd have to have a way of calculating the biomass of what you're looking at and plugging it into a spreadsheet or whatever to get the accurate biomass of like fungal to bacterial ratio and how much you have of everything.
I mean, it's really not that costly. So let's say you're $1,000 into it by the time you take the class, you buy the microscope. I mean, that sounds like a lot, but you own that knowledge forever. You own that microscope forever. And some farms are buying 10, 20, 30 yards of compost a year at $30 a yard. So,
right.
What are you actually buying? I mean, can you see a situation where or maybe of situations where farmers are over applying poor quality compost and they could get away with applying a lot less of better quality compost?
I think it's totally worth it to spend a little bit more money if you have to get a better quality compost that's focused on the biology in there. It's basically an inoculant is what you can consider compost when you're putting it on the soil. You're inoculating the soil with good biology. And so if you have something that's not a good inoculant, like you want to bake a cake and you buy the yeast to bake the cake, but the yeast is dead, what good does it do you? But you need that live yeast. That yeast is going to be an inoculant in your cake, basically, to get going. And so when we consider compost an inoculant, I think people can grasp the concept a lot better than it is providing nutrients, but it shouldn't be considered like a fertilizer. Should be considered an inoculant more, in my opinion.
Given that, this is another question that's been on my mind for a long time. Is there an upper limit to the amount of these organisms that you can apply, or is there a law of diminishing returns? Obviously, these are organisms that will self-regulate their population based on their food supply. But could you get to a point in soil where adding more compost, applying more compost tea, you're not getting as much of a bump each time, because at a certain point, like, that biology is going to be as active as possible. You're going to have as much organic matter as you can cram into that soil, and just doing more because it makes us feel better might not actually be doing anything for the soil, and you might be wasting time and money.
Yeah, I've got a few different answers to that. So, a quick description of succession in the soil for people who haven't ever heard of succession. If you Google a picture of plant succession or succession in soils, at the very beginning stage of succession, or if we were to take a piece of just even like a 3x3 little piece of land and take all the vegetation away and then let it go, at first you're going to get some pioneer weeds, dandelions, plantains, things like that, and then you're going to get some grasses after that. And then maybe next year or in a couple of years, you're going to get brambles and bushes that come up. And if you leave it for 10, 15, 20 years, you're going to have a forest eventually come up, coniferous deciduous forest. So as you move along in these stages of succession from pioneer weeds, that's the very beginning of succession, the soil there is bacterial dominant. And then as we move into like bushes, tall grasses, row crops that we grow a lot, that's going to be what has been found to be about equal bacterial to fungal ratio, 1-to-1 ratio. And then as we move into forest systems, we have the same amount of bacteria, but we have way, way, way more fungi in the soil that's helping these woody trees. With that sense, there's multiple things I can say with that. As we talked about, when you're tilling and breaking up this fungal hyphae or using chemicals to kill weeds, you are also having a detrimental effect. You're having a detrimental effect on everything in the soil, but you're setting yourself back in succession. So you till that land to get rid of weeds, but then you set yourself back at the beginning stage of succession. And what's the plants that come up because of that bacterial dominance? You've got weeds coming up. And so with that, if you've got an extremely bacterial compost that you're applying to land and feeding a whole lot of bacteria, but then you don't have their predators to come in and eat them, you have these pulses of bacteria that are just going to keep creating weeds and keep creating weeds. Also, with the talk I said about succession, it depends on what plant you're trying to grow. So, someone who's got just an apple orchard or a nursery, or who is trying to focus on trees, they're going to want to use a compost that is fungal dominant, or they're trying to get more fungi going in their soils with the trees, where someone who's growing lettuce doesn't really want much fungi. So depending on what plant you're growing and where that plant lies in succession, succession has to do with the amount of bacteria to fungi in the soil and ratio of that. So it all depends on what kind of plant you're trying to grow, or plants you're trying to grow, as to how much biology you need in the soil. Does that explain it well?
It does. And it's kind of echoes what I thought. I watched the video with Dr. Elaine this morning, and she kind of talked a little bit about that. And it just echoes a lot of what you're saying. Given that we're growing vegetables and this fungi to bacteria ratio is around 1-to-1, weeds are, I forget the number, but it was something like 100-to-1 in favor of bacteria. And you go to a forest and it's like 1,000-to-1. Could people who are into this wood chip gardening be potentially setting themselves up for failure if they're growing vegetables? Because at some point, that 1-to-1 ratio goes too much in favor of fungi, which is for these higher order species, not what you're trying to grow in a vegetable garden, and your soil's out of whack for vegetables, because you're providing that food source for fungi to break down. All these wood chips, fungi can have a field day. You can get this proliferation of fungi. If you remove the wood chips and you just have compost being applied, you leave, say, root mass in the soil, I don't feel like, and I might be wrong on this, that you're introducing as much food for fungi so that balance stays closer to that 1-to-1.
You're absolutely correct. Yeah, so as I mentioned before, in a compost pile, more green material is going to be food for bacteria, and more brown woody material is going to be food for fungi. And so by using wood chips in your garden, you're promoting fungi, or you're likely promoting fungi. And so, you'll notice that people who grow lettuce and use wood chips as a mulch have issues even kind of from the beginning. Another part of it has to do with, and again, I don't have a chemistry background, so I'm not able to explain it fully, but the nitrogen cycle. So when you've got bacteria breaking down organic matter and helping to release those nutrients for plants, they're producing more nitrate. And when you get more fungi in the system, you're working with more perennial type stuff, and you get more, the form of nitrogen is ammonium. So plants that are in the later stages of succession are going to be working with fungi more and using more of the ammonium form of nitrogen, and plants in the earlier stages of succession are going to be using more the nitrate form of nitrogen. The nitrates put out bacteria more, and the ammonium's put out by fungi more. And so it's a matter of what you're getting from that, what's being released from that biology.
So to really recap everything we've talked about so far in the first 40 minutes, I think we've established that you want compost that's fungally rich. So you're going to need to build that pile with food sources for fungi in addition to bacteria. So if you're just using all vegetable waste without a woody component, you would probably have less fungi.
You're going to have less fungi and you're going to have nasty compost. If you've ever seen anyone who's just like put food waste in a bucket trying to compost their food waste, it turns into a slimy, nasty mess. You need it. Yeah, you need brown material for a number of reasons. That's the chemistry between browns and greens going together is what really sets off the composting process more, where you're getting that action from the microbes that's increasing heat and things like that. Yes, it does happen in wood chips and things like that, but that's composting. So, but yeah, you need brown woody stuff for several reasons in a compost pile. You want it to help add foods for fungi, but the brown woody material is also what's going to give some structure to the compost pile. So in that same sense, you want different sizes of material when you're building a compost pile. You know, if you when you put something in a blender and or chop something up very small, you're creating that much more surface area, which you would think would make sense. If you're creating that much more surface area, you get more microbes that could move onto the surfaces, right? You get where I'm going? So if you had like a flour, think of how much that powder form, you've got tons of surface area for microorganisms to break down, but there's going to be no breathability if you had a giant compost pile that's the consistency of flour or a powder like that. So you need, it's kind of small, medium, and large things in a compost pile. If you're using food waste, you want to mix some leaves in there, maybe some straw, some wood chips. So the wood chips are going to be some nice fluff where it'll help give it little pockets of air where moisture can move in. The same as with soil, we want good soil structure, which is what these microorganisms are going to bring about, is the chance for air and water to move through the soil. We want that same thing in our compost pile. So we want a variety of, not only a diversity of plants and stuff going into the pile, but we want different sizes of things. But yeah, again, you asked about, so me personally, I'm trying to get more fungi going in any pile because most soils that we come across are degraded and need more fungi. So it's been my goal to always increase fungi. But if someone were a lettuce farmer, they're not going to necessarily want to make compost that's heavy in fungi because they're just growing lettuce and they don't need that much fungi anyway. So they do need some brown material, and it's a matter of when you get into that, it's a matter of the ratio of ingredients in your compost pile. So you'll hear different people mention different things, and I think on average, people would say what I hear or read is 50% browns to 50% greens, or 2/3 browns to 1/3 green, somewhere in between there. But yeah, in the sense that I was talking about, green stuff is food for bacteria, brown stuff is food for fungi. If you're trying to get a more bacterial dominant pile or trying to get more fungi going, then you'd want to have your ratio in your pile have more green than brown stuff. Or if you're trying to get more fungi, you're going to want more brown than green stuff. And it does come to a point where you can tip the scale too far either way. Like if you've got 90% brown material in your compost pile and 10% green, you're going to get compost, but it's going to take a really long time because you've got a lot of energy stored in that carbon from the wood that needs to break down, and it's going to take a really long time. in the same sense, when you have too much green, that's what I mentioned before, and you don't have enough brown, then you just get a pile of slop. You don't get any, there's really no consistency to it, or the consistency is slop. There's no structure to it, is what I meant to say. Where it just doesn't turn out as good compost, good quality compost. So yeah, in that sense, to give people some instruction, if you were trying to build a more fungal dominant pile, or trying to get more fungi in a pile, I would say don't use more than 70 to 75%. 75%, yeah, probably at the highest, browns, 25% greens. And it's hard in the same sense, probably if you're trying to get more bacterial dominant compost, I'm trying to think, because I'm never trying to do that, so I don't really think about that. I wouldn't go more than, 50-50 even for a bacterial dominant compost. Or just, maybe not as many wood chips and just other types of brown sources that might be easier to break down than wood chips. So you might not get as much fungi going. Can you repeat that? You cut out a second.
Less mature carbon, something like a corn stalk that's dry versus a wood chip. All right, so I'm talking to Troy Hinke of livingrootscomposttea.com. Troy, one thing I think people could be saying at this point in the episode is, how do I know where I'm at? Are my soils bacterially dominated to the point where I need to come in and apply compost teas to up the fungal ratio? I need to apply fungally dominated compost to up the compost ratio. If you're just applying and you're growing, you might be getting good results, but how do you know if you could be getting better results if you change that ratio? A lot of, I think, what you do around soil and applying teas is correcting soil issues. But let's go to somebody who doesn't have poor soil. They have pretty good soil. How do they know if it couldn't be better? They're just not doing the right thing to make it better.
Well, observe nature. What plants are coming up? Are you having pioneer weeds, or are you having tall grasses and brambles start to come up? What is nature showing you? And again, I'll refer to my succession thing. If you look at what plants are coming up, you're going to get a general idea of probably where your soils are at in the bacterial to fungal ratio. But I also need to point out again that it's not all about just bacteria and fungi. Bacteria and fungi are going to break those materials down and hold that minerals and nutrients in their body. But if they're just in the soil holding those nutrients and minerals in their bodies, you're not getting that nutrient cycling going. So the plant's not being able to absorb anything if the bacteria and fungi are still just present. It's also a matter of having protozoa and nematodes present that are going to eat those and poop them out and give you those nutrients. So in that sense, it really kind of does take a microscope to know that you've got the predators present. If you've got healthy plants that aren't susceptible to diseases and pests, then, most likely you're doing really good.
You think the presence of pioneer weeds is a reliable enough indicator to give a good indication of soil conditions? Like, I hear this and it's one of those things, like, it makes sense to me, but part of me questions it and says that is more myth than truth.
From the soils that I've looked at that are weedy, it's absolutely true that there's not really any fungi, and there's really not a lot going on at all in those soils. And as a matter of fact, because of compaction, if you might have some weedy areas that actually, if you get down to it, and those pioneer weeds might not have that deep of roots, so they're kind of just tapping into the top few inches there, but you might have a compaction layer that's 1 foot deep, 2 foot deep, 3 feet deep, that the roots of your crops would potentially be growing into. And if you've got a compacted area, it is possible that you've got an anaerobic dead zone where, if you've got a compaction layer in the soil, which most people, that's why they've got deep plows, that they're trying to hit that compaction layer. But at that compaction layer, you've got the dead pan where water passes through the soil, it hits that dead pan, and then it just sits there, usually like a puddle. And you and I can't lay face down in a puddle. We're aerobic organisms. We can't lay face down in a puddle. So these dead zones, the biology in there are anaerobic. It shows anaerobic biology. The biology in there shows anaerobic microorganisms. And like I said before, anaerobic microorganisms are usually creating a number of different substances that are going to be detrimental to plants, especially alcohols and phenols. There's other ones that I'm kind of blanking on at the moment. But, if you were to try, people take a cutting of a plant and put it into a jar of water to let it root out. Well, if you were to take, even half a jar of water and add 50% tequila to that and put your plant in there, is your plant going to survive? No. So when these plant roots are growing down and they hit that dead pan, they've been working with aerobic microorganisms. They're shedding off exudates, putting out foods for microorganisms, and growing down deeper. And then they hit this dead pan, but the anaerobic microorganisms have, created all these toxic things that are detrimental to those roots that it's then not able to grow down, and it may even grow out. I've got a great picture. Elaine uses it in her talks, where there's a tree that's a huge tree that, the canopy on it has got to be like 30 or 40 feet across. And if you were to picture that in the soil, you should have that same root zone, at least like a 10 or 20 foot root zone that's coming down into the soil. But these roots grow down 5 feet deep, and all of a sudden they start shooting sideways because it's hit a compaction layer where it's breeding anaerobic microorganisms, and those roots can't work with the microorganisms, and then it's looking for better soil, better microorganisms to work with. So yeah, you could even have potentially dangerous, potentially detrimental soil that in a compacted area like that.
So let's say we want to work on that compacted area. We have it. We're going to remove the tool of some sort of deep tillage. We're going to remove the tool of plant-based biology. So we're not going to use like a long tap-rooted crop like a tillage radish to get down there and bust it up. Can you apply a liquid soil drench in the form of a tea that can go down there and try and outcompete those anaerobic bacteria to change the soil biology there, which would then allow the roots of the plants that you're growing to be more efficient at that hard pan?
Yes. I've got a root injector. So part of my business is going out and doing compost tea sprays for landscapes, lawns, gardens, and farms. And I normally use it's similar to like a paint spray gun, but I also have a root injector. And the idea behind that is to get good compost tea into the root zone, especially possibly in a compacted area. And a couple weeks ago, I posted on Instagram of Japanese maple that I'm working with. I'm actually sitting like 15 feet from it right now, where I'm trying to get good biology going into the soil, into the root zone, so those roots can work with the biology and help to build structure there. And then that biology is continuing to work and grow out and reproduce, and then it's working on this structure of the soil around that. I know you said without tillage and without roots, but I need to say that, I'm talking about using a no-till system, or I'm coming across as talking about a no-till system in agriculture. And yes, we need to get to where we're no-till, but there's, especially in Tennessee, we've got really bad clay soils, and, you can't just start off with putting a seed in a hard clay soil. You need to kind of break it up some and get something going there. So I just want to put that in there, that normally when you are starting, at least the first time, you're most likely going to have to broadfore or till, hook up compost tea applicators that are going to be hooked onto your deep till method. So you're tilling at 2 or 3 feet deep, and you've got good biology that's coming out of that same depth. Otherwise, you can also use cover crops to help feed the soil and help create structure like you're talking about with the daikon radish. Otherwise, normally, if you're using a soil drench or compost, I've got a great video from way back on Instagram again, where I had inadvertently left some compost on the top of the soil in my yard. It's hard clay soil, where if I tap my finger on the soil, I can't make any penetration into it. And then just a few feet away, where I just happened to leave a couple inches of compost that had been sitting there for a year and a half, maybe. And I went over there and stuck my finger in, and my finger could go down like up to here, like a good 4 inches. So the biology, like I said, you're inoculating the biology onto the soil. And what happens is it slowly works its way down through the layers of soil. And I mean, it's pretty slow. It's not going to happen, overnight or in 1 month. It's going to be several months. But it slowly works its way down, creating structure deeper and deeper into the soil. And with that, with the microbial breakdown in the soil, you're attracting more worms who are also then going to be coming into there, creating soil structure, breaking things up, kind of working the soil for you. So in that sense, I had left a pile of leaves, a pile of straw, and something else in a place in my yard with the intention of building a compost pile. And whatever life happened, and I didn't get to it, and it sat there for maybe 6 or 9 months. And then I took all that material and moved it somewhere else to make a compost pile. But everywhere underneath there, because it was kind of like a mulch layer or whatever, and there were microorganisms there, worms had come up and already made the top 2 inches of that into nice pliable soil, just through the action of worms and obviously microorganisms too. So yeah, if you're not tilling and just applying compost, it's going to be a pretty slow process. If you're wanting to get good soil, I would recommend, if you're having, if you have a really hard clay soil, both clay soils and sand soil that are heavy in sand need organic matter in there to help create more structure. So putting compost down is helping to get good biology and helping to get good organic matter on there, which is going to help the microorganisms to build more structure and worms to build more structure. So yeah, tilling and then adding compost on top of that, and even putting down a compost tea to really get good biology going. And then, so that's getting life back into the soil. And then we need to keep life going in the soil by always having plants in the soil to feed the soil. So that's the importance of cover crops and companion crops. So, while in the off season, you've got a cover crop going, but also while you're growing your crop, you've got companion crops that are growing alongside. And it's a matter of picking out the right ones that are going to be a good structure, where they're not going to shade out your cover crop and they're going to cover the soil nicely. But it's always going to be continuously feeding the soil, keeping that soil, the biology in the soil alive, which is then going to be able to feed all the plants that you have there.
Given that a lot of these soil organisms that we're talking about that are beneficial in a vegetable-based system, and that's really where we're talking about here on the evolution scale, they're aerobic, they require oxygen. Do you think there's some detriment to those organisms in a pure no-till system? So I look at a no-till system and I get the idea behind it. You're trying to mimic nature, and it's really combating 100% pure tillage, which I see as really bad. But if you go in pure no-till, that's mimicking a forest, which there we have this huge fungal to small bacterial ratio. If I'm applying compost teas, if I'm applying compost, I need air to get into the lower levels of the soil so those organisms can proliferate. Can I rely just on biology, whether that's microorganisms or larger organisms in the soil like worms, to provide enough aeration? Or should I be looking at ways that I think are close partners to no-till, whether that's broad forking on a small scale or subsoiling on a larger scale, where you're allowing the soil air pathways into the soil without inverting the soil Is that beneficial? Or again, are you doing more damage by breaking up that fungal network that is there in trying to get air to the aerobic microorganisms? Do you have any thoughts on that?
I do, yeah. From my experience and from the experience of a number of other people and research, it has shown that if you get the biology going and through plants, you can get the structure of your soil to where you don't need to do any other additional methods. So like Gabe Brown is a great one to listen to on any podcast. And I would like to correct one thing that you said, is that you mentioned that, through trying to get the biology going or no-till, we're trying to mimic a forest system, which we're not necessarily trying to mimic only a forest system. It depends on the biology. So, if we look back in history, the Great Plains were covered in grasses. They had a good amount of fungi in the soil, but then buffalo came along and disturbed that soil either by trampling it or eating it. So there's some disturbance in that. So yeah, you may need to incorporate some disturbance, but I would say that it shouldn't be drastically moving the soil around. Yeah. So to quick reference Gabe Brown, I was listening to a podcast with him where he was saying, it was in the 1990s. It was like 25 years ago or something like that, when he was first starting out on his land in an hour's rain event. His soil could hold a half an inch of rain in an hour, and through his using good biology and cover crops, he said that he can now absorb 29 inches of rain in an hour. And that's all about soil structure. His soil is just like a sponge now. So then it's holding the water, holding the air for future use. And there's so many benefits to that. You think of how much topsoil is lost in the Midwest or all over the United States right now, into waterways, and chemicals going into those waterways. If we were able to hold all those, especially with the heavy rain events that we're getting due to whatever you want to, climate change, whatever you want to call it, it's obvious we're getting crazy weather events with extreme rains and things like that. And if we were to work with nature like, Gabe Brown has, he's able to tackle this and take that on and not have any detrimental effects.
Yeah, I mean, the grasslands, I think, are a great example, because there you aren't really getting any tillage other than prairie dogs and maybe things like that. Your company, Living Roots Compost Tea, you deal on the compost tea side of things. To start kind of big picture here, why is compost application not enough? Why should somebody think about adding tea to the mix in addition to applying straight compost?
There's advantages of compost tea. It's really all a matter of your needs when it comes down to your farm. So if you have compost, like I said, most people are applying 10 tons per acre. Think of how much compost that's going to need. And that's all about inoculating the soil with good biology through that compost. You can take a very small amount of compost, like say for an acre, I'd use probably, 15 to 20 cups of compost, very small amount of compost, brewing a compost tea by adding microbial foods. And the idea is to, add aeration, agitate it, and get to a peak population where you've got a lot of bacteria, you've got good protozoa going, and then you're not using that as inoculant onto the plants and soil. So you've got the advantage of being able to provide a foliar application, but you're also able to use a lot less material and time to inoculate soils and plants with good biology. So like I said, you're using far less compost. And if you think about the equipment that you would need to haul out that much compost, 10 plus tons onto a piece of land, compared to taking a four-wheeler or any other type of a backpack sprayer, or on a large scale a tractor, it's going to take a lot less time and energy to apply compost tea and use that as an inoculant than to get compost down. But again, as I said, it depends on your application and what your need is, because a lot of people are their soil is needing that organic matter. So it would be good to get a compost down. I mean, there's a number of things I could talk about with compost tea. You could take compost tea and use it as an inoculant on bad compost. Like, what if you've got compost that you don't think is that great? It's not breaking down very fast. Spray it with some compost tea, get that many more microorganisms going on there, and help your compost break down faster.
Well, what about this? Let's say someone has a farm. They've applied compost over the years, so their organic matter is up at 8-9%. Organic matter is not a problem. They're in a no-till type system. They're leaving a lot of roots in the soil. So organic matter, let's say a lot of that's being replaced by roots. If we ignore for right now the exporting of minerals from the soil. So if we harvest lettuce and sell it off property, we've mined some minerals from the soil and we've exported them. If we throw that out right now, and that's not a consideration, could we survive by just applying compost tea, not compost? So we're inoculating that soil and adding more bacteria and fungi and organisms to the soil from tea, a liquid, versus a solid compost, and just get off the compost train for good?
Yeah, you could. This is still questionable to me, and I would say that I'd have to disagree with Elaine's statement. Elaine's always made the statement that all soils have enough nutrients and minerals to feed a plant, and it's a matter of getting biology going in those soils to access those minerals and nutrients. And I can't say I fully agree with that. I do believe, and I'm not an expert on remineralization, but I do believe that it's also more effective to incorporate remineralization, or like in my compost teas, I like to add azomite, and I don't use a ton. I could probably even put a little bit more into my compost teas, but I'm trying to get, those micronutrients and minerals going along in with the good biology and the nutrients from that biology to put back on the soil. So yes, I believe it. I believe at a point you're going to need more than just compost tea.
Maybe at that point it's focusing on that higher grade compost, so it's less of a volume thing and more of a quality thing.
Yeah, right, correct.
Compost tea, I see there's really two categories out there. There's compost teas for the soil, and there's compost teas as foliar feeds or foliar protectants, amendments, however you want to actually call that. What are the differences between the two when you say go to brew them, biologically speaking, or is there a difference? Would you use the same tea on the leaves that you would on the soil?
I don't know about other people's experience with having two different types of teas for foliar versus soil application. I don't necessarily go by that, but I will say this can get very confusing. So compost tea, to get very specific, is where you put compost in a mesh bag, put it in water, you're agitating that water for a certain amount of time or adding air to that water and adding microbial foods. And the importance of compost tea is the addition of foods for microbes. So you're feeding microbes, getting them to reproduce. So just say, it's far greater than this, but say you start out with 100 microorganisms, you're feeding them and trying to get them to reproduce to 100,000 microorganisms. Through that reproduction, the bacteria and fungi create glues, which helps those microorganisms to be stickier. So when you're providing a foliar application, it's much more likely that the microorganisms are going to stick on the surface of whatever you're spraying. It's great to put that onto soil, but you don't necessarily need that on soil. So you could use just an extract on soil. An extract is different from tea in that you're putting compost in a mesh bag, you're putting it in water, and you possibly are aerating it, but you're not putting any microbial foods in there. So you're extracting those, what I said was 100 microorganisms, just say 100 microorganisms. The point is to extract those 100 microorganisms into the water, but then you're not getting them to reproduce. So you're not getting those glues from reproduction, and you can put that onto the land. If anybody's just a quick kind of how-to, like if anybody was interested in doing that, you could kind of increase your population by putting compost in a bag, extracting it, dumping out that compost. Now you've got 100 microorganisms. Refill your bag with compost. Do the same thing. So now you should have 200 microorganisms. You can increase the population that way without adding foods. But at a certain point, you're getting so much sediment in there, you can't keep doing that because you're going to clog up your applicators. Also, quick note, I may do an extract, but then I'm not trying to get, the whole idea of the foods is getting microorganisms to reproduce. I'll make an extract and then put it into a sprayer or whatever, and then add foods for microorganisms like humic acid or fish hydrolysate. That's going to benefit the microorganisms that are in the soil, but it's also going to be foods for those microorganisms that you're spraying out into the soil that will help them to proliferate once you get it onto the surface of the soil and plants. So I'll do that same thing with, compost tea. And again, I know you didn't ask this question, but for people who are interested in applying compost tea, we did experiments at Rodale at 5 gallons of extract per acre with a large-scale corn farmer. And not to get off the subject, but this is a guy who was doing research with Monsanto in the 70s. He'd been a chemical salesman. He did research with Penn State, who does both conventional and organic research, but then known to do a lot of research. So this guy was really big-time chemicals. When we first met with him, and Elaine was talking, he was using the term snake oil all the time in reference to compost tea. He was very skeptical, more skeptical than yourself probably. I went out with him to put in an application at 5 gallons per acre, and it was supposed to be 500 acres. We ended up doing 100 acres. And I went out with him at the end of the season in his harvester, his combine to harvest, and he was telling me, he's like, before I even get my numbers back, and I can already see that I've got more corn going, and I even had some damage from deer, and I can tell that my crop this year is going to be larger than other years. And he went on to work with Rodale for another maybe 2 or 3 years. I don't know if he still is or not, but that was at 5 gallons per acre. My point behind this is I normally do 20 gallons per acre, but still, if you think about that little amount on a whole acre, it's very hard to get that little amount on a whole acre. So you need to dilute compost tea down. And in the water that I dilute compost tea down in, so, say you've got an acre of land and it takes you 50 gallons to spray that whole thing. So then you would want to dilute your tea down into 50. I think I said 50 gallons. I may have used the wrong word. It takes 50 gallons to cover that amount of land. You'd want to dilute your tea down, if you're using 20 gallons, 30 gallons of water, 20 gallons of tea equals 50 gallons, and then you'll spray that out. So in that water, what I'm getting at is that I will add foods to my water so that it provides more food for the microorganisms that I'm adding in with the tea to help even feed it more once it gets onto foliar and soil surfaces.
So here he was the skeptic turned believer. And I think this is where skepticism comes in. As humans, I think we have a hard time believing things that we can't see, at least immediately, because we've been just sold a bunch of snake oil, like you mentioned, in the past and everything. And I look at something like tea, and the question I always see people ask, and I often ask this of myself when I've made them, is how do I know that it's actually working or doing something positive? And by doing something positive, I mean, am I going from a 1 to a 1.5, or am I going from a 1 to a 100? For me to go to a 1 to a 1.5, that's great, but is it worth the time? maybe not. And this isn't just the compost tea thing. It could be any of these minerals that they sell in all these catalogs. They get this marketing spin on them that promises so many good things, but for the end user at home, what can somebody look for if they're doing trials with compost tea on their farm, in their garden, and say, okay, what change should they realistically expect to see with their eyes?
With everything with this, it all depends. I mean, depending on your soil, depending on the quality of compost, depending on the quality of compost tea, depending on your plant, you only go to a 1.5, or maybe you go to 100. There's so many conditions and variables that are dependent on that. Like what if you apply a great compost tea, but then like you had some crazy, I can't even think of a weather event that might come in, but like something weird that affected that biology and then kind of negated it. My experience and what I've heard from other people is that normally their first application of compost tea, they will notice possibly a drastic difference, or at least some things that they can, some slight variations that they can notice. But then upon further applications of teas, there won't be as like drastic of a difference, and it's usually because that biology hasn't been present, and then the plant gets the biology and it's like, whoa, party time, like I finally get what I need. But then it's kind of comfortable and it's got that. It may need some extra, but it's not going to show the excitement in future applications. I will tell you, yeah. What really did it for me? So I took a 20-day class with Elaine at a university that I went to, and then I wanted to apprentice with her on the microscope because I had no experience with a microscope. I went to Rodale to apprentice with her, and that's how I ended up getting hired there. They liked me a lot. But anyway, the point is, I saw the results that she was getting enough to convince me that I was like, I want to do this. I believe in this, but I didn't have my own personal experience. And I kind of went nuts when I went to Rodale. It was like this perfect time where this guy had just happened to donate two compost tea brewers there because Elaine had just started there and I was there, and like I took advantage of all that and I just went nuts making compost tea all the time. And I went out I couldn't apply anything to their organic stuff because of regulations, but I could apply stuff to the stuff they were growing for a CSA, community supported agriculture. And I went up to the tomato plot, and it was like 4:00 in the afternoon. I had gotten off from work and I was it was on my own time. And I sprayed one row of tomatoes, it was like 300 feet long. And I left several other rows. The foliage. So these are tomato plants that were 3 to 4 feet high. It was late summer. They're starting to flower and fruit. So they're at the beginning of their flowering stage before they're fruiting. I went out there in the afternoon to spray compost tea, and I sprayed one row and left several others just to see if I could notice any difference. That day, the flowers, the little yellow flowers from the tomato, were all hanging down like this, downwards. I came out the next day, 24 hours later, and took pictures. I took pictures the before and I took pictures after that. So 24 hours later, I went out there. The row, my left hand, or this hand, is the row that didn't get compost tea. This is the one that did get compost tea. All those flowers, almost every flower on the plants that got compost tea had turned up towards the sun like a satellite like that. The ones that didn't get compost tea were still facing downwards. And I was like, holy shit, this stuff works. I mean, it really convinced me.
Maybe a misconception around compost tea is I think people think, okay, well, there's a bunch of nutrients in that tea. There's nitrogen and potassium and phosphorus and trace minerals. And that's what's enacting the plants to respond. I don't think that's true. And correct me if I'm wrong. I think it's more you're applying microorganisms to the plant. The plant is responding to the plant microorganism interactions. What part of that or none of that is true?
Yes. From what I understand in my experience, all of what you just said is true, that it's all about the microbial interaction. Yes, there are nutrients in there, but it's not the nutrients, it's the microbial action that is giving them the advantage, or that's what they're gaining from. Yes.
So for somebody at home who wants to start, what's a basic recipe for compost tea? I have a bucket, I have water, I have a bubbler, I have some good quality compost. Do I need anything else?
So in any presentation, not the cheapest way you can make compost tea, you can get a bucket for free even by going to the bakery section at a grocery store and get a 3 to 5 gallon bucket. You go to a paint store, you get a $2 to $3 paint strainer bag. That's a 5 gallon bag. It has an elastic top. It fits perfectly on a bucket. It's like made for brewing. The most you're going to spend is on like a $20 to $40 aquarium pump that's going to pump air into there. And then compost. So with my quality of compost, I use 3 to 5 cups per 5 gallon brew. I'm normally more on the three cup side. You really don't need much. And then, you could do just an extract and get results from that, not add any foods. But if you want to add foods, so there's bacterial foods and there's fungal foods. The only bacterial food that I recommend, or that Elaine talks about, is unsulfured blackstrap molasses, which is something that you can get at the grocery store. Then fungal foods, there are different things. The main ones that I like to use are humic acid, fish hydrolysate, and then I like to either use feather meal or kelp meal or soluble kelp. And in a 5 gallon brew, I'll use a tablespoon of humic acid, possibly 2, but I don't go more than that, and a tablespoon of fish hydrolysate and a tablespoon of kelp. So I'm not doing more than 3 tablespoons altogether in the whole thing for 5 gallons. It just really needs to keep it minimal, because you're working with microorganisms that are tiny, they don't need a ton of food. Most people think that more is better, but not in this case. So minimal foods. So yeah, a tablespoon humic acid, tablespoon fish hydrolysate, tablespoon kelp or feather meal. And then if I were to use a bacterial food, the unsulfured blackstrap molasses, I would only put like half to 1 teaspoon in a 5 gallon bucket. And normally you've got enough. The fish hydrolysate is going to also be food for bacteria, and we've normally got enough bacteria going in our compost that we don't really need to get that going that much more, because we're trying to get other microorganisms going more. And then I've got a table that's a rule of thumb that I put together on Brew Time. So Brew Time for a compost tea really is dependent on the ambient temperature outside, which has an effect on the oxygen in the air as well. So in the springtime, in March and April, when I've got cooler temps and it's getting down to 35, 45 at night, but then in the daytime it's getting up to 65, 70 degrees, I'm brewing for 2.5 to 3 days to get to peak population. In the summertime, it's a lot hotter. The microorganisms are more active anyway. It will take, in the middle of the summer, I don't normally brew in the middle of the summer, but in the beginning of summer, say, it's only going to take, if it's 75 at night, 95 during the day, it's going to take only, 24 hours to brew. And because of that, you're trying to get to a peak population. So the population of microorganisms are growing. You hit a peak population, and then all of a sudden they've run out of food and they've used up all the air, even if you may have been oxygenating it, and you quickly go anaerobic. And so it's a matter of hitting that peak population. And the problem that many people have is that they're brewing for too long, and then you're getting those anaerobic microorganisms going. If you ever need to err on the side of brewing for too short. So if you think it's too hot out, brew for just a few hours. Like I said, that guy in Pennsylvania, we weren't even using foods for micro. We were using extracts, so we weren't increasing the populations. and that was 5 gallons per acre, and he was getting results. So if you need to err on the side of being not brewing long enough, or what you think would be long enough.
Is there a visual cue for brewing too long?
There's not. A lot of people think it's great to like see foam in compost tea. Like, foam really doesn't have anything to do necessarily with microorganisms. Yes, they do create a little bit of foam through their reproduction, but not the kind of things that I see people on YouTube videos talking about. It's normally because you've got a thick substance like fish hydrolysate that's getting air pumped up through it. So like, just when you're a little kid and blowing on milk, blowing in your glass of milk and creating bubbles, it's kind of that same thing. The only cue that I have noticed is, once you start to get this, the only way I can describe it is a wet straw smell. So it's kind of a gross smell if you've smelled straw that's sat around wet. Once you start to hit that, I would say you're either at peak population or you need to use it then. If there are cues that it's gone bad. If you smell anything bad, so same thing with a compost pile. Our noses are meant to detect bad things, and we can rely on our own devices. So if you smell something that is very off-putting to you, it's going to be off-putting to the microorganisms, especially because they're a lot more sensitive than we are. So in a compost tea, if you smell like a manure smell, it's definitely gone anaerobic, and you probably don't want to use it. Another thing I do need to mention is that compost tea is made with compost. If you put soil, and because people get this idea, oh, I need a fungal dominant brew, so they'll take what they know is fungal dominant soil and put it in your brew. And I can't say I haven't done that. Yes, I have. But you're taking the chance that there might be a pest or disease in that soil that hasn't gone through the composting process. Using pathogens into your brew. So in that same sense, I believe it was Penn State that did, I think it was in the 90s, it was either in the 90s or early 2000s, and that did compost tea experiments and research, but they were using manure. Manure is not compost, manure is manure. So they were making manure tea and breeding E. coli and stuff like that. So these people who are introducing bat guanos and stuff like that, I'm not necessarily saying you're going to get bad stuff, but that's not necessarily a strictly compost tea. Compost tea is using compost. And I apologize, but I meant to touch on this briefly way back in the conversation, but you had mentioned cold composting. I just want to mention this real quick. The reason that we want to get up to temperature on a compost pile and go through what are called PFRPs, practices that reduce pathogens, is because those hot temperatures kill pathogens and weed seeds. And so that's the benefit of having a hot composting process, is because we're hopefully killing all the pathogens and weed seeds that are in that. In that same sense with the smell, if you've got a compost pile that you smell ammonia, you're losing your nitrogen in the nitrogen that's in, not all the nitrogen, but the nitrogen or the stuff that you smell, you're losing so much of that nitrogen as a gas form of ammonia. And so the nitrogen that you should be keeping in your product is getting lost in a gaseous form, as well as that compost is going anaerobic. Or if you get like a sulfur smell, that's also going to be, I can't think of the nutrient that it is, but you're losing that nutrient in a gaseous form. So anytime you smell something bad, you're not only losing nutrients, your pile has gone anaerobic, and you need to get air immediately into there and turn a pile.
Thinking compost tea here are some of the big mistakes potentially. One, adding too much molasses or any molasses, which is something I personally know I've done in the past. You've mentioned it. I've heard Dr. Elaine mention it, that there's already enough bacteria there. You probably don't need to breed them out. So adding molasses, not a lot of bang there for your buck in terms of what you're going for. Two, brewing too long. And then three would be using soils where you're potentially introducing pathogens into the mix. Any other big mistakes you see people make?
Water quality is the only other thing I can think of. I mean, you really need to start with good water quality. I mean, people talk about this on just watering their garden. You know, when you're using water from a tap, if you're in city water, it's going to have any amount of chlorine or chloramine, and that chlorine or chloramine is put into the water to go through the pipes and kill any bacteria that might be collected along the way so that we don't consume any of that. And in that same sense, that chlorine or chloramine is going to be working against any of the biology that we're trying to grow because we're trying to enhance these bacteria. So you want to off-gas water or treat that chlorine or chloramine. If you're using tap water, say, you get your 5-gallon bucket out, you fill it up with water from your tap, you can let it sit out for 2 days to off-gas that, 2 days or more to off-gas that. You also want to be getting your water to ambient temperature. I'm gonna come back around to that in a second here. So you can off-gas it in a couple days by letting your water sit out. You can put your air pump on there and let it sit for 12 to 24 hours, and that should off-gas by bubbling it. It'll increase the rate of the off-gassing, and you should be able to off-gas that chlorine or chloramine in a matter of 12 to 24 hours. Or if you aren't able to do that, you can use humic acid. And again, because I don't have a chemistry background, I'm not able to describe how this works. But there's something about humic acid and any acid that it binds to the ions of the chlorine or chloramine and ties up like one of the oxygens or something. I don't know. I'm not even going to give you a wrong answer, but there's something about it that it ties up chlorine and chloramine. So you can use humic acid to tie up any of that chlorine or chloramine. And it really takes a minimal amount. According to Elaine, you just need to put enough humic acid into the water where the water even just becomes tinted brown. So that's like 5 to 10 drops of humic acid. But I'm normally using, a tablespoon in a 5-gallon brew. So that treat that. Like I said, I just wanted to mention, like with brewing, you want your water at ambient temperature. And when you're brewing compost tea, you want to brew at the same ambient temperature that you're applying it to the plants. So if you've got a greenhouse that you're wanting to apply plants to, don't brew it outside and then bring the water into your greenhouse. Or don't brew in the air conditioning of your house and then bring it outside into 90-degree weather. And you may have heard Elaine talk about this. She was working with, I think it was the Bellagio. It was one of the places in Las Vegas that she had consulted with. They had a great brew program going. Landscape looked fabulous. And then the summer came and they started having a bunch of issues that they thought was a result of the compost tea. And so she questioned them, couldn't figure out what it was. And then she went there. Finally, they paid her to come out and check out what was going on. Well, they had moved their brew operation from the outside to an air conditioning environment for their own comfort. And they were brewing, in the 70s and then taking it out into a desert and having issues. So you want to always brew at the same ambient temperature as what you are applying it to your plants.
Yeah, I think the water is an interesting point, and that's something through all my experiences, I've seen people really freak out about the amount of chlorine, chloramine in the water. And my unscientific opinion is there's not enough in there to matter. You're putting so much compost in relative to the amount of water that bacteria is going to outcompete the chlorine. It's just like if you had a 5-gallon bucket full of water, go to the bathroom in that 5-gallon bucket, I'm not going to be confident in drinking that water. That chlorine is going to kill anything in there. So, I mean, those are my thoughts on that. But people, they freak out about too much chlorine in the water. But I think you're right. You just bubble it, and that solves that problem if you're worried about it.
And I'm kind of the same opinion as you. I feel like usually the chlorine's not going to have that much of a detrimental effect on the biology because we've got so much biology. But you never know how much. I mean, like if you smell chlorine, there's a lot in there, and it's good to treat it. So yeah, and because you're using humic acid as a food anyway, you're likely tying that chlorine up. Like it's not usually a factor that I am extremely concerned about. But it's good to focus on water quality. And if you can use rainwater, even better.
Right. Use the best that you have available and then do the best you can with what you have, but don't get paralyzed into not starting.
Else. Yep.
So let's say that the tea's now brewed. We made this optimal tea. I want to go apply it to my farm, into the garden, put it in a sprayer straight up. Should I dilute it down? What's the best method of applying?
The best method of applying is whatever is going to be best for your application or whatever you've got. So, someone with a small garden, if you've got flower beds around your house or a small vegetable garden that you normally use a watering can for, put it in a watering can and go water it. If you, it all depends on how much time you want to spend applying, So backpack, to go from like the smallest to largest, watering can, backpack sprayer, water pump with a sprayer like I use. I've seen multiple different things. That large scale with that guy, he was using a drip emitter on a boom from his large tractor. That's like a 40, 60, I don't even remember how big that was. It was a huge boom on a drip emitter, spray emitter. I've worked with someone, I sold them Compost Tea. They took out four-wheeler. They've got those tanks with the 10-foot boom or whatever on a four-wheeler. Use that. And then, you can apply it at full strength if you need to. Or like I said, it really just depends on how much water you need to be able to apply it onto the land that you have. So in a boom like that with the four-wheeler, he was able to put strictly Compost Tea into the tank and apply it without diluting it down. If you were with myself, I'm using I use a Honda water pump hooked onto an IBC tote with a 200-foot garden hose and a spray. So I'm having to dilute down, a couple hundred gallons normally. And I'm normally wanting to do that also because I want to really make sure that the soil is moist, to give a good moist surface for that biology to continue to survive and thrive. And I'm not just spraying it on a dry surface. So, like I said, if you're a farmer that has 1 acre and it takes you 50, from your experience applying other stuff, that it takes you 50 gallons to cover your whole 1 acre, then dilute it down however you need to cover that 1 acre. And I don't know where the breaking point of diluting it too much is. Normally you can't really dilute it too much, or it doesn't come to that point where you're diluting it too much. It's just a matter of, and that might mean if you don't have experience with applying stuff out on your land, it might just mean a matter of seeing how much water it takes to cover that amount of land in the application that you're using.
Do you think you can over apply? It's cheap. You can make it at home. You can essentially make infinite amounts. I mean, is there a danger of putting too much?
I've been asked that at different times, and I can't honestly answer that, but I don't see how you could. I don't see how you would have the time to make enough to really over apply it, especially if you're like a market gardener or something like that. You've got enough other things going on. I think that having the time to apply it as much as you could would be more of the issue. I have noticed, so I had a fiddle leaf fig tree in a potted plant in my house, and I applied Compost Tea to it a few times, and the soil in that broke down so much that it was like humus, that it like almost broke down too much. So it can, depending on your climate, if you're in the Southeast where it's humid, you're going to get a lot more it's going to be a lot easier for you to get microbial action. So if you've got a cover crop that you chop and drop or use a flail mower on, you're going to break down a lot faster depending on your climate. So if it's going to be detrimental to get that breakdown too fast, then you could be applying too much Compost Tea. But I would say most of the time, it's not going to come to that point. I hope that answers it well.
Do you have any thoughts for market gardeners applying Compost Tea to leaves that will be consumed? Lettuces, kales. Food safety is a big thing nowadays, especially with the coronavirus. That's brought that all to light here. What are your thoughts when it comes to applying tea to a part of the plant that you're going to eat?
If you're using a microscope and you know what you're doing and you know what you're looking at and you know how to identify disease microorganisms through the microscope, and you have full confidence that you don't have that in your brew or your compost, I feel safe. I feel safe spraying it on any plant. If someone, like, I'll tell customers or other people, like, yo, it's totally safe for your dog, your kids to go out and play in this. Like, right after I sprayed Compost Tea, I was like, it's totally safe for your kid to go out here. And if they're kind of questioning, I'm like, if you want, I'll spray it in my mouth right now. Like, I'll drink the Compost Tea myself. Like, I'm not worried about doing that. And other people do drink Compost Tea. Yeah, like when we were at Rodale, just kind of a funny story. We had a class of kids who, I think they were thinking that the Compost Tea was like tea, and so they wanted to try it. And we sprayed, everybody lined up and they wanted to have it sprayed in their mouth. So we sprayed it in a bunch of little kids' mouths, which I'll admit that years later now that I can't get in trouble for it. But, nothing happened. And again, it comes down to making sure you have safe compost, and you wouldn't want to be, that's where it comes down to the microscope, I should say. That's the importance of using a microscope to look at what you're doing. But to be on the safe side, it'd be good to follow regulations to where you're applying that, 30 days before harvest for eating. But I have no issues. I've sprayed at I have friends who own a farm like 2 miles from me. I've gone by and sprayed their stuff, and then I knew that they harvested that stuff the next week, and I buy a CSA from them, and they've most likely cleaned it a little bit, but there may still be stuff on there, and I'll eat it without washing it, or I'll pick stuff that I've just sprayed and eat it. I don't have an issue with that.
Right. So, I mean, when I think compost tea, I think going in initially, a lot of my thought would be around applying it to the soil, where it sounds like a lot of what you're applying to is direct to foliage. Is that, like, if you had to recommend one way to use it, is it on the foliage versus the soil?
I would say the most important thing is the soil. So when I'm going out, I didn't clarify that. When I'm going out spraying, what I normally do is, if this is the plant that I'm applying it to, I'll hit the foliage up here, and then I'll zoom in and soak that root zone. And so I'm getting a foliar spray and a soil soak in the root zone of the plant. But the most important thing, as I am trying to point out, is the matter of getting that biology into the soil so that the soil can feed the plant, and inoculating the soil.
Well, along that, here's one thing I hear a lot of people talk about when it comes to teas is, in the tea brewing process, you've created kind of this perfect environment for these microorganisms to survive. You're giving them tons of oxygen, tons of food. You're starting them out really vigorous and healthy. They're going nuts. Now you're relocating them to the soil, which may be non-optimum conditions. Are they actually surviving in the soil, or are you seeing like a rapid decline in population because soil conditions aren't potentially near where brew conditions were, so it might not be as effective as thought?
Yeah, that's a great question. I point this out to people, or I've learned to point this out to people. If I go and spray a farm who doesn't have a lot of mulch down and they've got pretty bare soil, and I can see that it's clay soil, a compost tea, the foliar spray is going to benefit the plant. The soil soak is going to benefit the plant a certain amount, but Maslow's hierarchy of needs, food and habitat, food and shelter. So we need a habitat. Microorganisms need habitat. And that's what I want to get across to people, is that the soil, you need to treat the soil as a habitat and try and make the most positive habitat that you can to further the microbes. So if you don't have good organic matter on your soil or in your soil, you're going to get a bit of benefit from the life that I'm spraying onto there, but there's not necessarily going to be a good continuation of it. So that's where cover crops and mulches come into play. through cover crops, you're not only getting the good exudates from roots that are feeding the soil, but once that plant dies or is terminated, you're getting that organic matter on the top of the soil that's going to also feed the microorganisms. And it's been shown that the preferential food source for soil microorganisms is first root exudates and second organic matter in the soil. So they're getting the benefit of root exudates, and then when the plant dies, they're getting the benefit of using that organic matter for food, and it's also going to create structure in the soil. So we need to give a good, healthy habitat to these microorganisms, which is the habitat for the plant as well. And so it's all about giving a good home to this for the soil and feeding the soil and then keeping that life there.
Is there a benefit to just applying food sources for microorganisms in the soil to the soil instead of actually adding the organisms to that liquid when you're applying them?
I get what you're saying. Yeah. So yeah, one of the main fertilizers that organics uses, or that I know of, is fish emulsion or fish hydrolysate. So people in organics are using that as a fertilizer for their plants. Well, what is that? It's a food for microorganisms. So what are they really feeding? They're feeding the microorganisms. Yeah, so if you've got good biology in the soil, I do think that there's a benefit to that. I can't say that I've ever done that just myself. But yeah, say you want to increase things in your compost pile. What if you just took some humic acid and fish hydrolysate and put it in a mix and sprayed that into your compost pile? You're giving all kinds of foods to those microorganisms to help feed them. Yeah, I totally believe that. Dan Kittredge, the Bionutrient Food Association, I think he has a great example of this. He talks about, like on cloudy days, if you've got multiple cloudy days in a row where you're not getting photosynthesis from the sun, you're not getting the root exudates being pumped as heavily into the soil because you don't have that photosynthesis. So he likes to use molasses mixed into water, diluted down into water, and sprayed out to his plants as a sugar and food source for those microorganisms to keep them fed and keep them going in the soil for times like that. And I don't want to say that's true or that I know that that's true, but according to my research and my experience, that totally makes sense.
All right, Troy, man, I really want to thank you for coming on today and sharing all this knowledge. I think a lot of people have a lot of information that they can go and work off of. A big takeaway for me is I want to go out and make some compost tea. I mean, I think why not? And that would be my call out to people listening to this. Why not try it over the summer when things are growing? It's not going to take a lot of money, and maybe, just maybe, you'll get some great results. Any final thoughts you want people to take away when it comes to compost and compost tea?
One thing I had failed to mention when we were kind of talking about the foliar spray is that according to Elaine's research and also my beliefs, is that if you get good biology onto the foliar surfaces of a plant, you're providing a protective surface where you've got a wall of beneficial biology that's going to keep diseases and pests at bay. So like tomatoes get blight in the middle of the season. And so it's good to have a foliar application to help prevent this. Again, that goes back to having a healthy plant and healthy soil to not attract those pests in the beginning. But I did want to mention that because I hadn't mentioned that. And so like with application rates, people often ask about application rates, which we didn't get into. And I normally say at seed, at first true leaf, and then 1 and 2 months later, or like with landscapes or lawns, I'll recommend 3 to 4 times per year. If you're doing gardening, I think it's good to get an application down once a month, or depending on your plant, like say we've got roses or tomatoes, which are very susceptible in summer months to fungal issues. So then you'd be wanting to get out there once a week or once every other week to get a good coating of biology on those plants. So that's what makes it good. And I'm not saying that's 100%. Just because you go out and spray doesn't mean you're not going to get diseases, because there's always things that happen. But I had wanted to mention that because I had not gotten to mention that in our conversation.
The seed thing is one really great thing to touch on quick here. I mean, I've heard people talk about inoculating seeds where you spray it, you then let the tea dry on the seed, the microbes go dormant. That way you can run it through a seed drill or a seeder. It gets into the soil. When moisture hits it, that biology reactivates, or you seed your plants into your cells that you're going to be transplanting from, and then you just spray that soil really quick so the biology is there in the cell when you transplant the seed, the plant, and the soil into the garden bed.
Totally. Yeah. So again, relating to this to humans, or any other animal, when mammals come out of the vaginal canal, they're coated with tons of bacteria that are giving them this coating that's a good start to life, which is a really good start to life. And it's been shown that people who have C-sections, their kids need to be inoculated with this good biology from the vaginal canal. I'm sorry to get into this on a gardening podcast, but it's good. It's really good analogy. So with that in mind, we want to start the seeds off with good biology, coating them with soaking them in an extract to get that good biology on the surface, or applying it as immediately as possible. I'll just mention real quick, because a lot of people are into mycorrhizal fungi, and that's not one thing we didn't touch on, but saprophytic fungi is what you're going to find in compost. You might have mycorrhizal spores, but mycorrhizal spores need roots to germinate. So even if you have mycorrhizal spores in compost, it doesn't mean you have mycorrhizal fungi in compost. So you can purchase separate mycorrhizal spores to inoculate seeds. Or also, I wanted to mention that earlier, is I don't always, but it's always great to add a mycorrhizal spore powder, soluble powder, into a compost tea mix. You can do that as well to get that into the roots, especially if you're doing root injections, to get that into the soil and help to benefit plants that much more. So yeah, in that same, when we're talking about that, when you're doing your seeds, coat them with extract and add some if they're a mycorrhizal, which 90 to 95% of plants have mycorrhizal associations. Put some mycorrhizal powder in there, because you're going to be using a lot less. It's all about money with most people. You're going to be using a lot less if you do it at a younger stage than if you're trying to do it at a plant that's big. You're going to be using a lot less, and you're going to be getting that good inoculation in there, which can then take off itself and thrive, rather than having to use more to get it going. So you're saving money by doing it you're saving money. You're getting the plant going better through that biology at a young stage of the plant's development.
Last great words. Love it, man. Where can people find out more about you if they want to learn about your services, some of the other things that you offer, and just follow along with the projects you're working on?
Yeah, the best place to follow along is on Instagram or Facebook, more like Instagram. I do a lot on there. I've got a website that's livingrootscompostea.com, and I specialize in soil microbiology, not in website building, so it's not the greatest website, but you can find out my experience and services and products that I offer there. Half of what I do is consulting with growers and composters nationwide. I can do it by phone or by email too, to give people help. The other half of my business is offering compost tea sprays in the Nashville and Middle Tennessee area, like I said, for landscapes, lawns, gardens, and farms. A quick ad, I've been considering changing my business name, because compost tea is not necessarily all I do. I've been considering changing it to Living Roots Biologics, because biological stuff is on a whole is much more on what I'm working with, like making compost. And I've kind of also been trying to get Nashville's first large-scale food waste compost facility going, using worms to compost. It's just been a matter of finances. So yeah, keep an eye out at Living Roots Compost Tea on Instagram, livingrootscompostea.com. If you want to email me, it's Troy, Troy, at livingrootscompostea.com.
Hi, everybody. Thanks for watching. Subscribe here to get the latest from the show. Also, be sure to check out some of the great clips and watch the full interviews right here on In Search of Soil.